What's up, guys, gals, and everything in between? Today we are talking about solving inequalities in one variable. I like to write my letter T as in spill the tea with a little curly Q underneath so that you can tell the difference between a T and a plus sign. I like to start with some steps. So the only difference here in solving inequalities is that we want to try to keep the variable on the left. It's going to help us put that on a number line. If we were to solve using the same steps as solving equations, we're going to go ahead and simplify the left-hand side and the right-hand side first. So over here you can see that I'm using the distributive property. I'm putting ones underneath my numbers so I can better multiply those fractions. I'm also going to bring down the right-hand side of the equation and I'm going to go ahead and simplify those fractions. Here I'm just using inverse operations to move those variables to the left and the constants to the right. I'm going to go ahead and simplify all that, and I did miss the equal to underneath the greater than. So there's just a couple of things that I want to go over before we finish this problem. When you get your answer, you want to put it on a number line. One thing that we definitely need to remember is that when we multiply or divide by a negative in an inequality, we must flip the symbol. Over here, when I divide by -5, I'm dividing by a negative. I am going to go ahead and flip that symbol. So this will become a less than or equal to symbol. Oh, I just realized I forgot that equal to symbol all the way down. So definitely make sure that you're getting through and putting those equal signs. My bad. 0 divided by anything is 0. I'm just going to put this asterisk right here just to make a note that that's why I flipped this symbol. I might even draw an arrow down here in another color. Let's go ahead and put this on a number line. So depending on your teacher, it does not matter to me how many numbers you put on here. I do like to put my number that I need to graph in the middle, and then I like to put maybe one number on either side. So here I'm going to put -1 and +1. So when we graph these, we need to remember when to use an open circle and when to use a closed circle. So I like to use these little faces just to remind me. Do remember that when you have a greater than or equal to or a less than or equal to, you use a closed circle because those values are included. And when you have an open circle, that means that those values are not included. Because this is a less than or equal to, I'm going to go ahead and fill that in with a solid dot. Now remember up here that we want to keep our variable on the left-hand side. That's because I'm going to just shade in whatever direction that is. Over here is -100 less than or equal to 0. Yes, so that's the correct way. But over here is 10 less than or equal to 0. No, so that wouldn't work. What time is it? It's time for you to try a problem on your own. All right, let's go ahead and try this problem on our own. Go ahead and pause the video here. Remember to use the steps that we just wrote down to try to help you figure this one out. Come back when you're done. We should have gotten f is greater than 4. We also need to finish our problem by drawing this on a number line. Three is definitely not bigger than 4, so we don't shade on that side. All right, so what you're looking at now is called a compound inequality. We call it a compound inequality because there's more than one inequality that we're solving in the same problem. So I'm just gonna put these lines here like I used in the last lesson. Cover up the sides and don't judge my fingernails. To get x by itself here, I'd start off by getting rid of that 4. I'm going to subtract 4 on every single piece. So notice I'm getting rid of it in the middle, and then I have 2 other inequalities that I'm solving. Right here, I'm just going to simplify, and then I'm going to go ahead and divide by 3 in every single piece. Here, here, and here. So -3 divided by 3 is -1. X is all alone. 6 divided by 3 is 2. So this is our answer. This is actually what we call an AND statement. Anytime you see this type of statement where you have a number is less than x is less than a number, this actually means between. You could read this as x is between A and B. So when I would read this statement, I would say x is between -1 and +2. Don't forget your number line here. I'm going to use closed circles here because I have a less than or equal to. Now, again, this means between. I'm going to shade between these values. Think about what I said in the last two examples with a test number. If I were to put this 3 in for this x, notice that if I use that 3, which is outside of my shaded region, it's true for the first half, but it's not true for the second half. That's why we have to shade in between. So for an and statement, both of these would need to be true in order to shade in that area. It's time for you to try. Ready or not, here it comes. Here's the you try. Go ahead and try this one on your own. Pause the video and come back. This is a 7. I do like to write my 7s with a little line through. All right, here's your answer. X is between 0 and 2. You could just remember that this means between and shade between those numbers. Remember, open circle when you don't have a line underneath that inequality symbol, when you just have strictly less than or greater than. You can also use a test number. So I'm actually going to put 1 in for x so that you can see how this works. So if I cover this up, the alligator mouth is opening to the bigger number. And if I cover this side up, the alligator mouth is opening to the bigger number. So we shaded in the right area because these are both true. So the opposite of and is or. So if we can have an and statement, we can also have an or statement. Okay, so this is also a compound inequality. The reason that we call them or statements is because they're going to end up pointing in opposite directions. This is very simple. You're just solving two separate inequalities. Let's go ahead and get this h by itself here. So I'm going to subtract 2.8 from both sides. I'm going to go ahead and multitask a little bit and do that over here as well. These don't always have to be the exact same expression. You could have two completely different expressions, and we might just look at one of those when you try. So h is all by itself. 8 minus 8 is 0, so we actually don't need that ending decimal there. 1 minus 2 is -1. Over here, same thing, h by itself. 8 minus 8 is 0, so we actually don't need that last decimal place again. And 4 minus 2 is 2. We're going to put both of these answers on the same exact number line. Notice how in both of these, my variable's still on the left. So this brings us back to our very first example. Notice also that I have a less than or equal to at -1, so a closed circle. And then I have a greater than, strictly greater than, open circle at +2. I'm going to follow the direction of the arrow. And over here. So notice how the and statement was between and we shaded between. An or statement, we're shading on the outsides. And, or. And, or. Let's go ahead and try another one. Shoop-de-doo-be-da. Ooh, honey. Go ahead and pause the video and I'll see you back when you're done. Okay, this is what you should have gotten. F is less than -2 or F is greater than 5. Open circles because you have strictly less than and strictly greater than. That's it for today's lesson. This was Miss Valdez. I'll see you next time. Bye.